I'm a technical evangelist with JetBrains. I just joined them in March, so I've been doing work with them for many years in their community program. You can catch me on Twitter or on my website. And if you're ever wondering what happens at STL Ruby, where I spoke last night, yes, it's only a flesh wound, right there. Tripped on the stairs, took out my elbow. STL Ruby is a lot of fun, so if you've got any interest in the Ruby crowd, that's a good group of folks to hang out with. So we're here to talk about JavaScript, and specifically about Testable JavaScript. And what does that mean? Why is it at all important? I'm a bit of a graybeard. I've been around for a while. This is the first browser I actually developed for. Yes, this is Lynx. I started web development back in the early 90s. Before there was JavaScript in web browsers. This is text only. No CSS. It's crazy stuff. And then this was Mosaic Netscape. Still no JavaScript yet. So we really don't need to test JavaScript because it doesn't exist. And then along came Netscape 2.0, which introduced JavaScript. And all the other browsers, like IE, jumped on the bandwagon and implemented a JavaScript engine. Back in the early betas, it was known as either very early Mocha and then eventually LiveScript. But Java was popular at the time, and so everybody jumped on the JavaScript bandwagon. And the reason that Brendan Eich, who was the creator of JavaScript, it actually had a much more functional style of syntax back when it was Mocha and LiveScript, and he was forced by Mozilla to add in semicolons and curly braces, which I always felt kind of funny. I'd really like to go back. I can't find any code from that era, and I'm very curious if it looks more like CoffeeScript. So back when, back. There we go. Back when JavaScript was first introduced, we had very simple things that were being done. You could really determine if the code was acting properly by inspection. There wasn't a lot of complicated stuff. Where it started becoming more important was with an invention by Microsoft with the XML HTTP object. And this was introduced in IE5, and specifically for Outlook Web Access. So they could do an email client. This was before Gmail. I actually worked on this system for a client, CP Rail up in Calgary, which is where I hail from. That's why I've got the crazy accent. I'm actually Canadian. But it was really neat to be working on using sort of asynchronous data coming in and reacting to this data coming in, rendering it out to the screen, and creating a full-fledged mail client. So there were a lot of interesting things going on, and with the advent of Ajax, we very much more needed better testing. Testing still didn't exist at that point. Things got more complicated with libraries like Scriptaculous and jQuery and jQuery UI. We've got a lot more logic moving onto the client side, less so on the server side, and so we're getting more logic over there, and that necessitates more testing. Why do we need testing? Because we want to make rapid changes. We want to be able to implement new features. How can we do that if we don't know that the code is obeying the rules that we've set out? I find programming to be a very strange occupation. Back in the 70s, it was very easy. Systems weren't that big. You could contain an entire program in your skull and really reason about what it was truly doing. Now, any reasonable sized system, our brains aren't big enough to know all of the interrelated parts. And so having tests around our code allows us to focus on the part that we're interested in at the moment and kind of push off all the other stuff. So this is becoming more and more important. It's become important on the server side. Now with Scriptaculous and jQuery, it's becoming important on the client side. This is even more so when we have rich single-page applications using libraries like Knockout or Backbone or Ember. We've got huge amounts of functionality. We've got templating libraries on the client side. We have eventing libraries like Postal on the client side. We've got MVC frameworks on the client side. That's a lot of logic to be contained within that JavaScript code, and it really should be tested. If this was in Rails or in Node or in C# or any other language, we'd have testing frameworks. So we really need something equivalent on the JavaScript side. A lot of this was pioneered by Kent Beck in test-driven development. A lot of the ideas around unit testing actually came from his work in Smalltalk. This book, Test-Driven Development by Example, is actually written in Java using JUnit, but previous to this, Kent pioneered a lot of the work inside of his work with Smalltalk with something that's been dubbed SUnit. That really didn't have an official name at the time. And there's been a lot of libraries that have come about that are based on this sort of XUnit type test framework. We've got NUnit in the .NET world, we've still got JUnit, we've got a variety of testing frameworks in the Ruby world. Every framework has, or every language has an XUnit type framework. CPP unit for C++. So this is becoming, oh, I don't want to join the network. So the whole notion of test-driven development and being able to test your code is now seeping into the JavaScript world. This whole notion of red, green refactoring. I've worked on projects where the back-end code was well tested. We did the whole pair programming, TDD thing on the server side, and really very little of it or none of it on the JavaScript side. And it resulted in a very interesting observation on my part, which was I could go into the server-side code and cavalierly change things. I want to rename this method, I want to change around a piece of functionality. I would just go in, change it the way I wanted to, run my tests, and see if it went green. And if it went green, I had very good confidence that the change I had just made did not actually break anything that either I had written or someone else on the team had written. That wasn't true of the JavaScript. The JavaScript we treated with kid gloves. We wanted to be really careful because even simple changes, like a rename, could break things unintentionally, where an event handler wouldn't get fired or something would go wrong, especially when you're dealing cross-browser. So all of a sudden we had this extreme confidence in our server-side code and a lot of trepidation when working with the JavaScript. So we did, going into a new project, we did a lot of work in the JavaScript to improve its testability. One of the things that we used was QUnit. QUnit came about from the jQuery project, from work that John Ressig and others on the jQuery team did. And it gives you this nice little test runner where you basically, it's just an HTML file that you can load up in your browser. You can load it up in an arbitrary number of browsers and see if the tests pass. And this gives you a lot of confidence. And it is very simple JavaScript code. We've got this, we want to say this is a module, or it's really a namespace. All these tests are linked together, and so we call it a module function. And then we have test functions, which takes the name of the test and then an anonymous function. And we've got an assertion library such as OK and not and equals, and there's a number of these. There's a very limited number, but they're sufficient for writing simple tests. And this allows us to gain a lot of confidence in our JavaScript code. So let me switch over. So if you want, to learn more about using QUnit, one of the best places I've found is to check out JavaScript cones. How many people have tried the JavaScript cones? Only one. Okay. I've got a link at the end. I want all of you to go home and do the JavaScript cones. It'll not only teach you something about QUnit, but it'll also teach you more about JavaScript. It's actually a really neat exercise. I use it when I teach JavaScript classes, where you actually go through and it's like, right here, it's like, okay, true, what will satisfy the OK assertion? what is the false condition in JavaScript. So these are the basic assert tests. If we actually go ahead and run this, so this is actually JavaScript cones, it gives us this nice little output. It makes a small change to QUnit, so it stops at the first failing test, so the student is focused on the last thing that they need to do. But you'll see I've got about operators.js, and that's failing. So I'm expecting the result incomplete, but that's not what I'm getting. So let's switch over and pop this open. So we want, which one was it? It was operators, that was the one. So we can learn about how to do addition in JavaScript. So you'll notice that there's this special, actually it's very functional. You'll see this in functional languages, the underscore to represent something that you don't care about. But in in here, they just define it as a variable. But what I can do here is, so what is the value of the result? Result is going to be 0, 1, 2, 3, 4, 5. So that's 10. Just adding in my head here. So that's going to be 1 plus 2 plus 3 plus 4 plus 5. I'm not going to try to do this one. Okay, so go ahead and save that. Refresh that, and it gives me the next example to work on. So it's a great way to learn JavaScript, but it's also giving me the syntax and examples for using QUnit. So it's a great way of learning how QUnit is, what its assertion syntax is, and for writing simple tests. You can also take another good source, there's another window, is actually, let's take a look at jQuery itself. It's using QUnit here to make sure that the dollars function is registered properly, that the jQuery variable exists, that certain prototypes exist on array, basically that jQuery is loaded and up and running. So jQuery itself, because that's what QUnit was designed for, gives us some great examples of how to test for these things. So you can kind of look through jQuery and find out what's happening. One thing that a number of folks were asking about is how you can actually test visual elements. Because just testing, classical example of using QUnit is doing credit card validation. You've got some credit card validation function that fires on the text box.blur, and you want to validate that it's a valid credit card, that it satisfies the mod 10 test. So you can write QUnit examples that test that the function, the credit card validation function, works properly. But what happens if you're actually trying to interact with the DOM? That gets a bit more complicated, and there's some good examples inside of jQuery UI, which also uses QUnit. So here we're testing out if tooltips work properly. So modules are just, once again, namespacing things, and we're looking at the markup structure. We've created a tooltip, and now we're making some assertions on the area described by is undefined, that the tooltip length hasn't been set when it's initialized at first, that it's only set once it's opened, all these assertions of how the tooltip is supposed to work, but this is actually using jQuery UI to create elements on the page and display them. So we can very well work with visual elements and test that they're doing the appropriate things, that we can examine that when a particular event is fired, that a class is added to certain divs. So very, very possible to do. Now, how does this actually work from a unit testing standpoint? I'll just switch back into jQuery here. So if I look at the actual project, it's very, very straightforward to set up. All the tests are inside of test, and there's this index file. And the index file, if I load it up in a browser, let's just open in browser, there we go. Oh, I need to be running it on a web server. So the jQuery tests aren't going to work there. But because we've got some rooted paths. But the basic idea here is if I open this up, it's just a bunch of standard web code. Minimally, we need to load in QUnit, and we need to load in the style sheet here, which is right here, just the QUnit.css. That's some configuration. This is all the tests so they've separated all the tests into different JS files just for organizational purposes. It's a bit of a pain, honestly, when you're dealing with a project to every time you add a new test suite, remember to add it to your index.js file, but it works. And then you've got certain known things like the QUnit header, banner, that's styled by the by the cascading style sheets. You can also have something called a QUnit fixture, and the fixture you can dump in arbitrary HTML that you can test on. So if you want the tooltip to be displayed on a div with a particular ID, you dump it into that QUnit fixture div, and QUnit will figure it out. It'll reset that div back to its original state after every test run, so you can run multiple tests on it. So it's a very simple, straightforward, lightweight tool to get it set up and running. So that's the positive side. On the negative side, there's certain places that it runs better than others. So if I've done it on .NET projects, getting this stuff into a .NET project to display the results as part of a CI process, it's an exercise in careful. Like, it's really I found it quite frustrating. It's not well integrated into the tool stack. If you're doing Ruby, it's brutally simple. The Rubyists have figured it out, and they've got rake tasks, and they run a headless browser, and yeah, it's just magic. That it just appears as part of the normal test run. The JavaScript tests get run just alongside the Ruby tests, and everything's wonderful. So it's one thing I do appreciate about the Ruby world is that they do have a lot of this stuff figured out, and they make it easy to get going. So that's QUnit in a nutshell. Is you've got this simple assertions framework that you can use. You write these tests. The tests are really just functions that you can execute arbitrary JavaScript code. This also works very well if you're a CoffeeScript fanatic. It looks a bit cleaner because you've got the arrow syntax rather than the more verbose function syntax. And very straightforward to implement all of these different tests. So QUnit is one testing technology that I've used, much closer to the XUnit. It is an XUnit style of tool. There's been a lot of interest in behavior-driven development frameworks, which is where Jasmine fits in. It's by the folks at Pivotal, which is a Ruby shop. So if you've ever how many people have done RSpec before, or seen RSpec? Or in the .NET world, if you've done MSpec, Jasmine looks a lot more like that. It has this context spec style of syntax. The context being the state of the world, and then you specify something about that, the state of the world. So I've got an empty shopping cart. If I look at it, then there should be nothing in the cart. That's the style that Jasmine uses. So a very simple Jasmine spec is, rather than test, I've now got to describe. You're more focusing on business functionality rather than on testing. We once again got the anonymous function, but we're describing a suite, and it contains a spec with an expectation, and there's this sort of expect. So if you ever used RSpec, there's a object.should equal something. Here we're actually using expect as a wrapper to return a specking object, and it has all these methods like to be, not to be, yes. Sounds very Shakespearean. There's a to equal, there's a lot of different matcher methods that you can call on this. And in a very English style syntax, express your intent. So let's jump over to, so right within the Jasmine code, the Jasmine code is implemented as, the Jasmine specs are actually implemented in Jasmine itself. So they specify their own library. So they're describing base.js, and I've got I can nest it just like I can with RSpec. And once again, this just runs in the browser. These are just JS files that get included. If you want to do this in CoffeeScript, and you've got something like the asset pipeline in Rails, it'll compile it down to JavaScript and run it the normal way. But we can actually go ahead and say, okay, these two strings should pretty print, etc., etc. And now you can put an expectation on the code that you've actually just executed. There's also before syntax, so that it runs before every spec, and there's an after that allows you to do cleanup. So it gives you a lot of these different functions. You've also, part of Jasmine is also a mocking library. So you can say, I'm going to spy on this current method, and so I'm going to be spying on current spec and the log method. This is kind of annoying because it has to be a string. You can't hand in a function. But what I've done is I've said I'm spying on this jasmine.log, handing its arguments, and then at the end I can actually look at whether that mock has received the expected arguments to have been called with 1, 2, 3. So Jasmine is got a lot of these nice little functions. It's much closer to RSpec in flavor. Having used both, I personally prefer Jasmine because it draws me out of the I'm testing something, which is kind of the wrong way to think about it. It's really you're designing an API. I'm designing my JavaScript code, and this forces me to think more as a business user. What is my intent rather than how am I doing it?
So you're saying you prefer Jasmine to Qt?
I prefer Jasmine to QUnit. I've used both on teams that I've been on. QUnit is easier to adopt because most people have done some sort of unit testing framework, JUnit, NUnit, something like that. So cognitively, it's an easier leap to say, okay, I've got these tests. I particularly prefer the more English-style business functionality type of fluent syntax that you get out of Jasmine.
So describing it and expect are all like global functions?
They're part of Jasmine.
Right.
So
how do you test something that's like would be asynchronous because you're outside of the call stack if you're like getting an event later on and you want to be able to test that?
A good question. There is a way of doing that. It's in the doc. Actually, it's got very good documentation.
Wait for.
Yeah, there's wait for. So you can. If you just go, I've got this link in there. This is the main Jasmine page, but it steps you through how to define suites, and then it's all just functions, the different expectations you can use. It talks about doing asynchronous operation, subscribing with. Yeah, we got spies. Down here, there's also additional things on spies. There's also discussion on testing asynchronous events, and that's all built into Jasmine. There's a wait for syntax. You can also specify, one thing I didn't talk about in QUnit is if you have you can specify the number of expectations you're going to get back, because one thing in JavaScript is it can fail silently. So if you've got you've got 3 physical expectations in there that comprise one logical thing that you're trying to assert, and the first 2 succeed, and then something fails in your JavaScript, so that third assertion's never called, it'll look like it passed. But you can actually tell it to, that's what's thrown over here. If you look at, for instance, jQuery core, that's what this expect 7 does. It's saying there should be 7 assertions in here, and if they're not, fail the whole thing. So even if you get down to here, you execute some JavaScript that causes things to fail, it will realize that it's only executed 4 assertions up to that point and failed the whole test because of it. Jasmine has similar.
Would they be able to see that an exception was thrown since it's wrapped inside that function?
For sometimes JavaScript it depends on your settings in JavaScript. I'm not sure why exactly it wouldn't be catching that exception.
Does it execute the test in parallel?
Does it? No, it doesn't. This is still JavaScript, so it's also
inside one function.
But there are ways both in QUnit and in Jasmine using like standard set timeouts. If your code is calling a set timeout, there's a way to delay and respond to that to make sure that your test waits for that to occur.
Because the testing frameworks that I've had more experience with, like you might have like a test function like that, but you're actually passing a context to that function that you have, so that way you can attach on things and run like your okays. It would be like your whatever context that okay. So that way you actually maintain like the context, its basic requirements, but it's asynchronous test, so that way you can do it later. And that's where like having and expect like a certain amount of tests to actually happen become more beneficial.
Okay. Back here. So yeah, Jasmine gives it a different, getting back to Jasmine, gives a different style of syntax, and that's really what it is. It's how you want to describe things. One of the other niceties of Jasmine, taking a look at this, is there's also a jQuery Jasmine, a Jasmine jQuery plugin, and that gives you a whole bunch of assertions around jQuery. So, for instance, in jQuery you are going to be doing some CSS manipulation, and there is an extension to expect to have CSS, and you can pass it in a hash, a dictionary of values here, and make sure that the CSS matches. So you do jQuery manipulations in your normal code, and then you've got matchers for jQuery to have CSS, to have class. There's a whole bunch of jQuery related things that you can work with. Now, if you are in the Ruby world, there's a cool little gem called Jasmine Rice, which bundles all this together and makes sure it all runs in terms of rake tasks and sets it all up for you. So you can just add in the Jasmine Rice gem into your gem file, and you get both Jasmine and Jasmine-jQuery all bundled in for you. So if you're a Rubyist, that's a nice place to play too. So I'd encourage you to take a look at both QUnit, see what you're comfortable with. Take a look at Jasmine. Our JavaScript is becoming increasingly complicated. We're pushing more functionality from the server side over to the client side. And just as on the server side, we need better testing to ensure that our larger projects remain maintainable, we need the same thing in our JavaScript code. We need more sensible ways of organizing it and ensuring that refactorings and changes that we're making, new features that are being added, actually do not break functionality that's already there. Libraries like QUnit and Jasmine go a long way to help us with this, and it's a very active area right now. There's a lot of different unit testing and specking libraries being developed for JavaScript. A lot of both QUnit and Jasmine do work with Node, so if you do need to do some Node work, you can write tests using these libraries for Node and have some more assurances that your JavaScript code is as solid as any other code that you're writing in your system. So if folks have questions, I'll be happy to answer them, or we can hack on code.
Yeah, I adopted QUnit a few months back for a project that I was working on. I really like it, but I'll be honest with you, it's much lighter and leaner than a lot of the other frameworks that I've used in the past, just because it's a lot newer, I'm sure. You say it's under active development. Is it going to be in the form of like things stacked on top of QUnit, or is it going to be like more primitives being added into QUnit, or is there any sense of how it's growing and going to grow?
QUnit is, I've been following QUnit for a while. It's remained really lean. It's really what the jQuery team needs as a bare minimum to make things work and to ensure that the development process is working. One thing that John Ressig worked on was something called Test Swarm, which is also uses QUnit. And what Test Swarm does is it allows you to run QUnit tests across a wide variety of browsers all at the same time. So you can basically set up Test Swarm to run on Safari on Macs, Safari on Windows, IE, Firefox, Chrome, all those different ones. And rather than having to manually load up your jQuery your QUnit tests in each different browser, it automates that process. So yeah, QUnit is very lightweight. There's not a lot in the assertion syntax. You are left writing a lot of, in my experience, when I've used it, writing a lot of helper assertion functions
That's exactly what
that you have to call.
It feels like I've got more helper functions than I do test suite sometimes, which is fine. But every time I write one of those, I'm like, am I writing something that's going to get added into QUnit here in the next 2 weeks?
I would say probably not, because the team, for the past at least 2 or 3 years that I've been following it, the API is the API. It really hasn't changed that much.
Are there libraries being built on top of it to provide some of the stuff that we're talking about? Because I'm sure that we're not the only two people writing a boatload of helper functions to run on top of QUnit.
I honestly haven't looked. I've gone down the route of writing my own helper functions and just doing what I need to do to make my QUnit tests less verbose. Wouldn't surprise me if some people have written helper functions on top of it, additional assertion libraries. Though honestly, I've gone more to Jasmine, which has both, between Jasmine and Jasmine-jQuery, a lot more functionality for assertions and a much richer library to work with. You were next.
How do you structure your tests so that you're not writing the same thing over and over again for each new test?
How do I structure? I tend to group functionality together in terms of modules. So I'll have a single spec.js file for a particular feature, like credit card number validation. And that will be in a single file that will then be included in that index.html file. And so for each major feature, I'll have a separate spec.js file that will focus on that. And I might have additional helper functions imported. It's, once again, web, JavaScript type technologies. So often, if I'm writing helper functions, I have to remember to include them in my index.html file before I include all my specs. So I have kind of a block of helper functions, additional assertions that I want to write, and then all of the spec library, all the spec.js files. You have to remember to include them, because I've also had that happen. It's like, oh, everything's green, and someone checks something in, and it's like, oh, that's not working. Oh, that spec file never got added to the index.html.
QUnit also supports setup and teardown functions too.
Yes. Yeah, there's also setup. So if you have common functionality, you can have setup and teardown functions at the module scope that will set up a fixture. One thing that we didn't talk about with, I mentioned it with QUnit, Jasmine also has a much richer fixture library. So with QUnit, you've just got a QUnit-fixture div, and you just jam in whatever you want right in the HTML. With Jasmine, you can actually have separate fixture files, which are just plain old HTML, and you can call in your actual Jasmine spec load fixture file name. And so right before anything gets executed, it will load that HTML into a div that's managed by Jasmine. So you can, okay, I'm going to be testing the accordion in jQuery UI. So it will actually set up an accordion, execute all the appropriate jQuery on it to turn it into an actual accordion control, and now you can run your specs on it. So that's another way to keep things organized, is by having these fixture files which contain snippets of relevant HTML that gets loaded in before the actual spec is run. Another question? Yes?
You mentioned headless browsers. Do you have any experience with any or recommend any libraries like maybe Phantom or something like that?
Phantom, in the Ruby world, Phantom's often used. So what Phantom JS is it's a headless WebKit-based browser, so you've got a full JavaScript stack. It's run in memory, there's no UI to speak of, but you do have a full DOM, full JavaScript, full CSS, and that's what is used in the Ruby world to make a lot of this happen. If you're looking at, I'm sure Node has something equivalent because they're kind of keeping pace with it, but if you're doing something in Java or C#, I know that when I looked at this about a year ago, it was kind of a mess, but you kind of can look to the Ruby world, see how exactly they're doing it for automating Phantom.js inside of Jasmine Rice to actually execute these tests in line with all the other tests that are being run in your application. But yeah, the Rubyists are far ahead of the game when it comes to actually running this as part of the normal test suite and being able to incorporate it in your CI process and report failures and fail the build based on failures in your client-side JavaScript code, which is just damn cool in my opinion. Other questions?
This is actually to help Bill out and other people may be interested. There's a library called Mocha which is a descendant of QUnit, cousin of Jasmine. In fact, it was written by one of the guys who originally worked on QUnit, another Canadian, TJ, I forget how you say his last name, but on GitHub he goes by Vision Media. But search on Google for Mocha.js test and you'll find it. But Mocha takes a very pluggable approach. So it sits somewhere in between QUnit and Jasmine. And people are developing lots of modules that get plugged into Mocha. So there's a library called Chai, which is an expectations library. There's a library that's totally dedicated to spies called Synon, and Synon can be plugged into Mocha. Actually, Synon predates Mocha, but some work's been done to make it integrate nicely. So, Bill, you might want to take a look at that and see if a lot of those helper functions may exist in the form of modules for Mocha.
Good suggestion. Yeah, as I said, like there's just a lot of activity happening in terms of JavaScript testing and testability, which is good to see because we are pushing so much functionality into our JavaScript with these rich applications.
Any more questions?